Hello friends, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with wave mechanics for chemistry, and this is lecture number 7. In previous lecture I gave you derivation of Schrodinger's wave equation. It is also known as differential equation. It is also called differential equation. And with the help of this equation, we will discuss wave mechanical model of atom. Well, the most famous equation is del square psi upon del x square plus del square psi upon del y square plus del square psi upon del z square plus 8 pi square m upon h square bracket E minus capital V psi is equal to 0. This is known as Schrodinger's differential equation. This is most famous equation. Now we will see interpretation of this equation. What is the interpretation of this equation? Well, here we can take del square upon del x square or y square or z square, which is known as partial differentiation. As we are differentiating this equation in 3 dimensions, and therefore we have to take partial differentiation. Okay, so del square upon del x square is equal to partial differentiation. Now, x, y, and z are Cartesian coordinates of the electron. As we are discussing atomic model, all these things are related to electron because we want to know how electron revolves around nucleus in an atom, and that is why all these things are related to electron only. For example, m is mass of the electron. In this equation, m is mass of the electron. Capital E, it is total energy. That means all kinds of energy of the electron. So all kinds of energy means potential energy, kinetic energy basically, and of course mass. V, capital V is potential energy. Please be careful, in this equation we are using capital V symbol which indicate potential energy of the electron but not velocity of the electron. Remember this please. So capital V stands for potential energy of the electron. H is known as Planck's constant. So even in equation of Schrodinger, we use quantum theory. Without quantum theory, we cannot explain wave mechanical model of atom. Okay, so this is related to quantum theory of an atom. Okay, psi or psi. This is basically Greek alphabet, but Schrodinger particularly this alphabet used for wave function of the electron. So psi or psi is wave function of the electron. So when electron is revolving around nucleus like on wavy path, its function, position can be given by this psi. So the wave function may be regarded as the amplitude function expressed in terms of coordinates x, y, and z. Or the wave function may have, so psi may have positive or negative values. Depending upon the values of coordinates. Okay. Well, this is one of the part of physics, and if we have to give any equation in physics, then it is always with conditions. So without conditions, we cannot explain any theory in physics. So there are certain conditions to accept this wave mechanical model or a values of psi. So first of all, let us discuss conditions for acceptable solutions of psi. Okay. So first of all, we'll discuss this. So acceptable solutions to the wave equation, that is solutions which are physically possible, must have certain properties. Okay, so without conditions, we cannot accept these solutions. So what are the conditions then? The first conditions, that psi must be continuous. Because it is a wave and wave is a continuous property, so psi also should be continuous. Then psi must be finite. Why? Because it is wave function of electron, and electron is revolving around nucleus. So there will be certain space around nucleus in which we find electron, and therefore the value of psi cannot be infinite. It should be finite. Psi must be single valued. Okay, so psi must be single valued. That means there should be only one solutions of psi for one particular point. If it has more than one solutions, then we cannot accept it. The fourth conditions, which you may not be able to understand right now, but I will give you, that is the probability, as Schrodinger also accepted the probability of finding electron, not the exact location, and therefore probability of finding the electron overall the space from positive infinity to negative infinity must be equal to 1. This is very important conditions which was given by Schrödinger. If you want to solve this equation, you have to follow this condition. So mathematically we write this condition like this, that it is limit of negative infinity to positive infinity psi square in three coordinates dx, y and z is equal to 1. That means it is equal probability in all directions to find out electron. Okay, so this is what four conditions of these equations are. Okay, I will explain you a little bit about these four conditions. Well, the elaborate explanation about this will be given in later stages, but at present just accept it. The value of psi which follows the above conditions is known as eigenfunction. Well, eigenfunction is a mathematical term, and I will explain you what is eigenfunction and eigenvalue later on. Okay, but eigen means proper, so it should be eigenfunction. Okay, and one more thing, that the value of E obtained from eigenfunction is known as eigenvalues. So eigenvalues are related to the values of energy level of Bohr's atomic structure. See, the eigenvalues are related to the values of energy level of Bohr's atomic structure. That means this was the time where everyone was rejecting Bohr's model, but only Schrödinger was the person who tried to convince the world that Bohr was not completely wrong, and he was in favor of Bohr's atomic structure. And how he tried to explain Bohr's model or try to convince Bohr's model also, that we will see later on. Thank you so much for this. This is enough in this lecture. Thank you.